Here we are with section 3 from chapter 4, Chemical Nomenclature. You can see the learning objective here, and it's pretty straightforward. We are going to spend our time in this section learning how to name chemical formulas based on 3 different types, and also go the other way and write the formulas when provided the names. As I just mentioned, there are 3 different types. Before I know which set of rules to follow, I have to first identify what is it, what type of compound do I have. Then I can follow the specific set of rules to name that compound. The good news here is that distinguishing between the 3 types is pretty straightforward. And we've already talked a little bit about this in our bonding sections leading up to this point. Okay, so to the left here, the first type of compounds I'm going to talk about, the first set of rules is for naming ionic compounds. Okay, now we've talked a lot about this. How do I know I have an ionic compound? If I have a metal plus something. Okay, so if my formula starts with a metal, anything from the left of the staircase on the periodic table, I'm going to follow this distinct set of rules. Okay, so first I'm going to focus on naming that metal, naming that cation. And there's 2 categories, as you know, that I could find here. One, metals from groups 1 and 2. We've talked a lot about what we know about these group 1 and 2 metals, which is we always know their charge based on the fact that they always have the same amount of valence electrons. So if I have a metal from group 1 and 2, all I need to do is just name it. I'll do some examples in a minute and you can see exactly what I'm talking about here. Additionally, I pointed out when we were talking about bonding and the different charges of the cations, there were a couple other atoms that didn't fall into this category, but we always knew that what their charge was going to be. So I'm going to include them here because we would also just name those. And that was zinc 2 plus, aluminum 3 plus, and silver 1 plus. So now we know that all the other metals, all the other cation possibilities are our transition metals here. And we know from our last section that these metals could have different types of charges. They could lose different amounts of electrons. So I can't just name these here. It's not enough information. So for these all other metals, we're going to name it, and then we are going to include a Roman numeral. You'll remember that the Roman numeral is used to tell us the charge of the metal in that specific compound. Again, we'll get to some examples in a second. So that handles our first part of our ionic compounds, the cation. Okay, so now let's talk about how do I name the second part, which are the anions. So we'll look at, we talked about we have 2 possibilities where we can find anions in our ionic compounds. The first were nonmetals. If you remember the elements to the right side of the periodic table, those are going to form anions because they're going to look to gain 1 or 2 or 3 electrons. For our nonmetals, we're going to name it, and we're going to change our ending to IDE. We talked about how there was not a lot of anion possibilities from just atoms on the periodic table. There's a limited number of nonmetals over there on the right side of the periodic table. But we introduced polyatomic ions, which the vast majority of the common ones that I showed you are anions. So the other place where I'll have a possibility of anions are polyatomic ions. And for these, we will just name it. Okay, so what does all that mean? Let's look at a couple of examples here. Notice I'm going to actually, if I go back to the top here, just so you know where we're headed, I'm going to do the next set of rules out in this direction and our third set of rules down below here. So if you want to create one kind of flow chart here for our rules, you can do that, and I'm going to do some examples down below here. Here we go. If I had this compound, I wanted to name it, I would always do, now granted we've only given you one set of rules here, but I would always do this idea of what is it, and I would see that magnesium is a metal, so this is an ionic compound, so now I'm going to follow this set of rules. Okay, magnesium falls into the category in rule number 1, which is it's a group 1 or 2 metal, so I'm just going to name it magnesium. Now I'm on to naming the second part of this ionic compound, which is the anion. That is a non-metal, chlorine, so I'd name it and change the ending to IDE. This ionic compound looks very similar, but I won't be able to name it quite as simply. Again, what is it? It's a metal. Now, iron does not fall into that category of rule number 1. So rule number 2, all other metals, I need to name it using a Roman numeral. Again, the Roman numeral tells me the charge of the metal in that particular compound. So we know about the crisscross method. So this 2 sitting here crossed over from the iron, and so this would be iron 2 chloride. Sometimes it's not quite as easy to see. I could have something like this. Okay, so copper is a metal. It's an ionic compound. It does not fall into category 1, but 2, so I need to name it using a Roman numeral. So copper. Now, where in the last example, the 2 was sitting there for me to see, there's no number written here next to the 0, next to the O, the oxygen that crossed over. So I actually now have 2 possibilities. The charge of the copper here could be 1, because we don't physically write 1s in our formulas, as you know, or it could have been the same as the oxygen, because you know if we try to cross the same numbers over, we actually cancel those values out when we write our formula. So while I may not know the charge of the cation initially, I will always know the charge of the anion. And so I know that oxygen has a 2- charge. I would expect to see that 2 in this formula when it crossed over right here. It's not there. So that tells me it canceled out, and so copper must have also been 2, or more specifically 2+. So then my formula here is copper 2 oxide. Okay, so far all of my anions I've used here are nonmetals. Let's look at a couple quickly that are polyatomic ions. So if I had CaSO4, okay, calcium is in group 2, so no Roman numeral needed. This would be calcium, and SO4 is sulfate. I could have had Na2SO4. Doesn't really change anything for me here. The fact that the 2 shows up shouldn't be unexpected, because in the last example, calcium's 2+, sulfite's 2-, sulfate is 2-, so they canceled out. Here, sodium is 1+, sulfate's still 2-, and so I get sodium sulfate. If I had this formula, I need a Roman numeral when naming this iron. So again, I need to think for a second, what is the charge of iron in this particular example? So sometimes I will see people put 4 because they're so used to just looking to the other side of the anion to see what number is sitting there. But in this case with polyatomic ions, I have to remember that 4 is actually part of the polyatomic ion, that one covalently bonded molecule that has a specific charge. So the charge on the sulfate is 2-. Here I am again. I'm thinking about, okay, the 2 should show up next to the iron after it got crossed. It does not, so that must mean iron is 2+. So this is iron 2 sulfate. Of course, I could have something like this. Okay, and that would be iron 3 sulfate. So those are the rules for name an ionic compound and some examples there. Okay, let's go now to naming covalent compounds or molecules. So from our bonding work that we've done already, we know we have a molecular covalent compound when we have two nonmetals. Okay, so what do those rules look like? So I don't need to worry about ions. I don't need to worry about charges. I do not need to worry about crossing charges. Now I'm just looking at the atom and how many there are based on the subscripts written next to them. Okay, so first atom, name it with, I'm just going to say numeric prefix and exclude mono. And for the second atom or element, we're going to again name it with that numeric prefix. And this time we will change the ending to IDE. So in those rules, I was referring to these numeric prefixes, and here they are. I've listed them here in the table for you. And here's how I apply these two rules. So if I were to have C306, then I would be naming this again, no charges, no crossing. I have 3 carbons and 6 oxygens. So I would say tricarbon. Again, name it with the numeric prefix. And now I would name the second part with its numeric prefix, which is 6, which is hex, oxide, changing the ending to IDE. Just a little point here, you may notice that I dropped the A off of the hexa because I've attached it to oxygen that starts with the vowel as well. Now I mentioned that we exclude mono in the first one. So for example, if I had this molecule, this would be carbon dioxide. We do not use mono if the first atom only has 1. We can use mono on the second atom, so this molecule would be carbon monoxide. So if the second atom has only 1, then yes, we would utilize the prefix mono, but if the first atom has only 1, then we are not going to utilize that prefix mono. So often students find this one a little easier to digest. There's not quite as much going on with the Roman numerals and the charges. I just have to commit this list of prefixes to memory so that when I identify how many, the number of each atom, I just attach the appropriate prefix. Okay, so the last set of rules here, we are going to name acids. So I know I have an acid when I have H plus something. So I have a hydrogen starting my formula, my compound off, and then there's something after it. Hydrogen, we're back to ions here, but we do not have to worry about Roman numerals because the cation is always going to be hydrogen. So that means the something I refer to here must be a negative anion because we're going to have H plus crossing with some anion. So we know from what we did with our ionic rules that a couple different places I can find anions. First being H plus A nonmetal. And what I'm going to do here is it's going to be hydro, the root of the element, change the ending to IC, acid. So I'm going to add, for a nonmetal, I'm going to add this prefix hydro. I'm going to change the ending to IC. So what does that look like? That means this, again, starts with a hydrogen, so it's an acid. I'm going to follow this set of rules. The second part, the anion here, is a nonmetal, so it will be hydrochloric acid. The other possibility we have for anions, as you recall, are H plus a polyatomic ion. Now, two common possibilities here. We could have that polyatomic ion be something that ends in ATE. In that case, it's going to be ic acid. Or we could have a polyatomic ion that ends in ITE, and that would be us acid. Notice here, no hydro. I'll talk more about that in some of our practice and examples, but it seems to be something that crosses people up. The hydro that I add in the front here has nothing to do with the fact that this compound starts with a hydrogen. They all start with a hydrogen. The fact that they start with a hydrogen is why I write the word acid at the end. The hydro is telling me the anion here is a nonmetal. When it's not a nonmetal, when I put my hydrogen with a polyatomic ion, you'll see there's no hydro in the naming here. Here's an example to illustrate the difference. If I had HClO3, again, acid, because it starts with a hydrogen. Now, this is clearly not an element. This is a polyatomic ion. That polyatomic ion is chlorate. So this would become chloric acid. Polyatomic ions that end in ATE become IC acids. If I were to have HClO2, that is now chlorite. So this would be chlorous acid. All right, so those are our three sets of rules for naming compounds: ionic, covalent, or acid. As I did each set of rules independently, I didn't always refer back to this key starting point, which is what is it? Often I will see students combining aspects of these different sets of rules. So once I determine it has a metal, it's two nonmetals, or it starts with hydrogen, I am then sticking within that set of rules. There is no intermingling here between the rules of these three different sets. We'll have lots of opportunity for lots of practice over the coming days.